So in today's lesson, we're going to be talking about different types of energy. We're going to begin with gravitational potential energy. Now, this is the energy that is stored as a result of the gravitational attraction of the Earth. So think about a roller coaster. Most roller coasters start by climbing a hill and they sit at the top of a hill. When it's sitting at the top of that hill, it has all of this energy stored, and this is because of gravity. When it rolls over the hill, it starts to move, which is a different type of energy, which we'll get into in a minute here. So increasing the height increases the potential energy. So if you think about a roller coaster, we've got a bunch of hills. There's going to be more potential energy on this large hill than on this smaller hill here and this smaller hill here. So the more height you have, the more potential energy you have. And the gravitational potential energy is equal to the work done to move that object. So, again, think about a roller coaster. Roller coaster is usually pulled up that first hill with some kind of a belt, and that belt is doing a bunch of work to move the roller coaster cart up to the top of the hill. So the next type of energy that we're going to discuss is elastic potential energy. This is a little different than gravitational potential energy. So energy is stored as a result of deformation of an elastic object. So think about a spring. If you have a spring and it's compressed, when you extend it out, when you make it a little bit longer, you can feel the tension on the spring, and when you release it, it kind of collapses back in on itself. That energy that's stored when we pull that spring apart here is elastic potential energy. There are plenty of other objects that have the same type of energy. If you think about any object that compresses or expands, that is elastic potential energy. Just like with gravitational potential energy, the elastic potential energy is equal to the work done to deform the object. And when we talk about deforming an object, that is just simply like stretching a spring in the example that I gave. Kinetic energy is energy of motion. And this is always present when you have an object that's moving. So you could say that in order to have kinetic energy, an object has to be in motion. So in this example right here, we've got a roller coaster that's going down the hill. It's obviously moving because the picture is blurred. So again, to have kinetic energy, you have to have an object that is moving. Thermal energy is a type of kinetic energy because it requires motion. So if you think about when you rub your hands together, you go really fast, eventually you'll feel that warmth start to build up in your hand. We're generating heat. The same thing happens in a car. When you slam on the brakes, those discs rub together and it generates a lot of heat. So kinetic energy is being transformed into thermal energy, which is that heat you feel when you rub your hands together. And in a sense, the energy is lost to the surroundings. So you're doing all this work to rub your hands together. They start to get warm. All that energy that you generated is transformed into thermal energy, and then it's being released into the system, the surroundings. Okay? And finally, we have total mechanical energy, and this is the total energy within a system. This is going to be the sum of our potential energy, our kinetic energy, and our thermal energy. And those are the types of energy that you need to know for our unit on energy.